Hey guys, and welcome to the second in-house video for the new manufacturing curriculum of the Department of Mechanical Engineering at the University of Utah. This video is going to introduce some basic hand tools and their important operations. So hand tools, what are they? They're the most basic engineering tools. Anything, you can think of this as anything you would use to build a design is basically a hand tool. Usually are operated solely by your hands, but sometimes they can be powered. Usually hand tools are small devices as well. And always remember, with hand tools, it's important to keep in mind that safety is top priority. You can hurt yourself just as much using a hand tool as you can using a larger manufacturing tool, as we discussed earlier in previous videos. So let's talk about we're going to talk about many different types of tools. I'm going to start with pliers. Pliers are one of the most useful tools you'll use because they enhance gripping potential. There are some places that we maybe are not able to get to very easily, or we just don't have enough power to grab onto these places. First plier I want to look at is a long nose plier. Long nose pliers are extremely convenient for getting into narrow spaces where a hand simply can't fit, and also provide some extra gripping power and rigidity for grabbing certain devices. Also notice that near the pin joint of a long nose plier is a small little black gap. This is oftentimes used, or often this is built into the long nose pliers as a cutting device used to cut wire. The next type of plier is called a slip joint plier. And a slip joint plier basically has a pin in the center, or a pin in the same place that a long nose plier would between the handles and the actual jaws, but this allows the actual jaws of the pliers to spread out and fit to different surfaces. It's very similar to a channel lock plier. Essentially, a slip joint or a channel lock plier is a type of slip joint plier, except it has oftentimes bigger jaws, a little bit different orientation on how the tool is put together, and it can spread the jaws at a wider angle too, a wider angle and wider distance apart. There are many other type of pliers, but these are just some of the basic ones that you should be familiar with. The second type of tool we're going to start looking at are called vice grips. Now, vice grips are a very unique type of plier. The main difference is vice grips have a certain mechanical advantage. If you look at the picture to the left, it shows a vice grips in an open position. The next picture shows the vice grips in a closed position. The advantage of vice grips are you can adjust them using the small round screw, as you can see on the vice grips, to get to be able to clamp onto a material. And the nice thing about them is they will lock in place, making it so that your hand doesn't have to provide a mechanical force to actually grip a tool. Vice grips come in many different shapes and sizes. Unlike the size you see to the left, where it has jaws which have teeth, you can see vice grips with small flat surfaces to get around other objects but still make a pinching force. And you can see sometimes jaws or vice grips with flat surfaces, as the one shown to the right. This kind of vice grip is useful for large flat areas of metal, or even if metal has been bent, these are very useful for flattening out that piece of metal as well. The next tool we are going to look at are files, and specifically when we're working in the machine shop, we're dealing with metal files. Now you can see many examples of files on the left-hand side of the screen here. They come in a variety of different cross-sections depending on the operation you want to perform. But basically all files work about the same. If we look at the surface of the file, it has a fairly sharp surface pointed in one direction. If we're actually going to do a filing procedure, what we do is, say for example, if we have a rough surface, we simply move the file in one direction along the surface and it smooths the surface out. Then, instead of going back on the surface, what we do is we bring the file back to the beginning of the surface and then repeat the procedure again, while each time removing more and more material. Next, we're going to talk about taps and dies. Taps and dies are tools which are used to cut threads into either holes or shaft. So the top tools you see the tools you see at the top of the screen, which are outlined in red, are called dies. The tools outlined in blue are taps, and there are corresponding handles for each of for either the taps or the dies. And either the taps or dies fit into these handles so that we can actually physically cut the threads into the surface. So as an example, let's look at die cutting first. For a die, let's say we have a metal post is shown in the figure, and the top piece is the actual die itself. So we put the die onto the post, and as we put it onto the post, we actually rotate the die around using the die handle. And as we keep rotating around and move all the way down the post, we get a cut thread from the die. Taps work very similarly in that they cut threads, but with a tap, what's actually occurring is we put a surface with a thread in it into a hole, and we rotate that around, and it actually cuts threads the opposite way. So theoretically, what you can do is you can take one member which has been cut with a die, another member which has been cut with a tap, and you can mate them together. Another tool we're going to look at is a vise. Well, vices are a very useful tool because they provide us a way of holding our work together and being able to use tools on that work. So a standard vise is something like you'll see at the left-hand side, where a mill vise is something you see to the right-hand side. So when we talked a couple videos ago about drill presses, the mill vise was actually used in the drill press. And mill vise used in both a mill and a drill press, it's basically a special vise that is fit to that machine so that we can set our material in that machine and perform operations on it. Hammers are a tool that I'm sure everybody has used who's watching this video. Hammers come in many different shapes and sizes. Basically, they're any kind of tool which is used to apply a blunt force on an object. Most likely, they're used for nails, but they're used for other applications as well. Standard hammer is something that everyone has probably used. It's mostly used for nails. A ball peen hammer is very much used in a machine shop. Specifically, we use a ball peen hammer a lot to bend and form materials, and also to work on a mill. We use a ball peen hammer to make certain adjustments. A rubber hammer is very common, and a rubber hammer is useful when we don't want to damage a material, but we do want to apply some type of force. And of course, an MC hammer, which hopefully everybody knows what an MC hammer is. Screwdrivers are used to attach fasteners. Basically, there are the two main type of fasteners we're aware of are flatheads and Phillips head screws. But there are many different types of screwdrivers depending on, well, of course, flathead and Phillips types can be used on flathead and Phillips screws, but there are many other types of screwdrivers we could use depending on what type of screw we're trying to screw in. And screwdrivers, as you see in this picture, come in many different shapes and sizes as well. Wrenches are used to tighten fasteners like screws. There are also many types of wrenches, like there are many types of screws. There's adjustable wrenches, crescent wrenches, and Allen wrenches. Now, adjustable wrenches and crescent wrenches are both used for hexagonal-shaped screws or bolts, where Allen wrenches are used for a very special type of screw or bolt. And finally, we'll also look at, well, no, not finally, we'll also look at drill bits, which are used with the drill to put holes in material. So we'll see something called a drill index, which is shown to the left, is actually used to put holes in materials. We also have these things called center drills. Now the important thing about center drills are they are used to start holes, particularly with drill presses and mills. Now I want you to all take a look at the geometry of the center drill versus geometry of the drill index. And notice with the center drill itself, that the drill bit is fairly wide in the center versus the very tips, versus the drills in the drill index where there's not as much material. The purpose of this is so that the center drill can really drill a very true hole. Now center drills can't drill very deep, but the primary purpose for them is to center a hole and make sure that it's quite accurate. And now finally, of course, we're going to talk about hand drills. And hand drills are, of course, what the center drills and every drill bit in the drill index is used for. So let's look at some of the basic anatomy of the drill. We have the keyless chuck, which is in the very front of the drill. Now the keyless chuck is the mechanism which holds the drill bits in place. We have the reversing lever, which switches between a forward and a reverse gear so that we can either screw something in screw something out or drill into a material and then back that drill bit out. We have a trigger, which is either can be variable speed as shown in this example, or just simply just turn the drill on or off depending on which kind of drill you have. A locking button, which prevents the on-off switch from going on or off. This is something in case like you don't want the drill to go off automatically, or just it's essentially like a safety feature. And of course a power cord if your drill is powered. Of course there are cordless drills as well, but this particular one is a power drill.